Hello, welcome back to math class. Today we're going to be taking notes and discussing misleading statistics. So what that means is that sometimes people will change the way the data looks in a graph or in the statistics just so that they can make a point or make it look better or worse than it actually is. Example 1 is showing two graphs that is presenting the same exact data. See, in 2017 it was at 3, 2017 at 3. 2020 it was at 10, 2020 still at 10. So the data is not different. They didn't change the data. But what they changed is the scale on this y-axis. This one goes by 2s. Whereas this one goes by 5s. So why would they do that? In this one, it looks, you can see gigantic changes over time. It looks like the ticket prices have gone up a lot from 2017 to 2020. But when they change the scale, over here, it looks like ticket prices haven't changed that much, that there hasn't been a big increase, and all of them look on the low side, whereas this one looks like it's a really high price. So if you are somebody who is complaining about the ticket prices, this would be what you would want to use. You want to say the ticket prices are way too high. But if you are somebody who runs the park, you might want to say, no, the ticket prices aren't that high, and use this one. So that's what we mean by misleading statistics. Let's look at example 2. This is a line graph. And again, this is the exact same data, but they changed the scale. Not only that, but sometimes they will add graphics and pictures to make something stand out. Like this person is probably trying to show their high weekly sales, which happened at week 5, and they had 50 sales. So they want to make sure that everybody knows they had 50 sales after week 5. They don't want to point out that they dropped in week 6. They want everybody to just focus here. Now, on this one, you can see that the scale is different, and this makes it seem as if there wasn't a whole lot of change in the weekly sales. There was a little bump, but then it's right back down to where it is. So if you're somebody who wants to say the weekly sales have stayed steady, this graph would show that better. This one would be more for people who want to promote the fact that there was a huge increase in sales there. All right, and then on the last one, we're looking at the statistics. Now, these are two students, Marissa and Jordan, and they're going to use statistics because they want to make their score, their grade, look as good as possible. So when Marissa looks at her scores, she would probably want to use her median, because if you put these in order, least to greatest, her median is 70. But if you add all of her scores up and divide by 5, so this was the median, her mean turns out to be 67. And so that looks like a D. So she's going to want to say my median score is 70. I have a C average. So depending on what you're trying to present to someone, you will choose your data, the statistics that you want to use. Now let's look at Jordan. Jordan, on the other hand, has a median. His scores are mostly above 80. So there's a 50 that throws them off, and then there's two 80s, but then there's an 85 and there's a 90. So if he uses median, median is a low B, but he has a higher B and he has an A. So let's see if we want to use the median, or maybe the mean would work better. So let's calculate this. So this is going to be 210 plus 175 divided by 5. And so that would, his mean, because of this low score here that he got, his mean is only a 77. That low score brings down his average to a C. So he would also want to use the median because the median score would be a higher representation of his grade. All right, so they can use statistics in different ways to present data in the best possible way. There we go. All right, so that's what we mean by misleading statistics. If you have any questions, please let me know.